there. Okay, hopefully we're unfrozen now. Okay, so picking up where we were, we're trying to get this thing written like this. Parentheses, parentheses, equals some number. Because we know once we have it written with these parentheses, we can change the sign, square root. So how do we factor x squared minus 8x plus 16? Oh, my my microphone has stopped working. So, gosh, Tim, you brought bad luck in here. Okay. So, I'm factoring this blue stuff. X squared minus 8x plus 16. It's going to be x plus or minus 4. Okay? So it's just that variable, the very next sign, and half of 8. Or the square root of 16, however you want to word it. Now, let's factor the y's. It'd be write the y down. Am I going to write plus or minus? Am I going to write plus or minus? Plus. And either half of 2 or the square root of 1. Either way, what number am I going to put right here? 1 equals, don't say 64. It's 64 plus the blue 16 plus the black 1. Y'all caught up with me? 81, okay. Now, what have we accomplished? Well, is it in the form we need it to be in so we can easily find the center and radius? Do we have the problem written so it looks like problems 6 and 7? Yeah. Now we can find the center and radius just by saying change the sign, square root. So let's see. What's the center? 4, negative 1. And the radius is 9. Oh, that's not a good, it's hard to see that. I've only been using red.
Change sign, take the square root. The whole point of doing this stuff here is to get it in center radius form. Parentheses squared plus parentheses squared equals a constant.
And that constant better be what kind of number?
If it's a circle, this number here better be what?
Better be positive, and it better be a perfect square so you can take the square root of it. Okay, let's
graph it. I mean, it could be an 80 and the radius is the square root of 80, but you're not going to be able to graph it using the graphing tool. So we come over here. Oh, they want us to graph it first.
No, find the center and radius. You don't type in any of that. You're just finding this here.
Oh, yeah. Do you ever just do it like this? Okay. Okay, and we click our circle tool. There's only one tool there that looks like a circle. And the radius was what?
Oh, the center is 4, negative 1.
The center was 4, negative 1. Now, be careful. It looks like they're incrementing in units of 2.
Oh.
So, there it is. Is that 4, negative 1? Look at that yellow box. Does it say 4, negative 1 there? I moved it. There. I click it. And now we're going to have to count up, down, left, or right 9 units. How about we count to the right 9 units? 4 plus 9, that would be what, 13? Is that, nope, I think I went down too low. Is that it? Yes, click it, save it to transfer it to the original graph, and check answer.
There's quite a few of these like this, so you'll get the hang of it.
What's the next one?
9.
9.
Okay, do number 9.
I'll do number 9.
Oh, okay, well,
I'll just talk loud. Okay, number 9 is the same type of problem. We're going to be graphing the circle, but in order to graph it, we need to know the center and the radius. So this is number 9. Let me write the problem down.
this is, this problem beautifully illustrates the most basic problem solving strategy. If you know how to do something like 6 and 7, problem 6 and 7, and you're confronted with a new thing, make it look like problem 6 and 7. Write problem 9 so it has parentheses in it.
Okay, let me make sure I don't miscopy it. Minus 8x plus 2. Okay.
Hey, Tim,
Okay.
I learned something new today.
You did?
If you don't like these numbers and you want to just change it like that, if you click help me solve it, boom, it changes the numbers automatically.
Oh, that's great.
Mm-hmm.
Yeah, I learned that.
Yeah.
Okay.
Okay. Start off by grouping the.
Oh.
Yeah. Oh,
We'll start off by grouping the x terms together.
with the
I've
plus
an-
blank.
I know. X squared minus 8x plus a blank. And now let's group the y terms together. We have a plus y squared plus 2y plus blank equals, what am I going to have over here on the right-hand side? Okay, I'm going to move that minus 8 over by adding 8. I agree. Hey, look at that. Number 9 looks sort of like number 8, doesn't it? Yeah. What are we going to wind up putting here?
It looks too much like
I know it does.
Okay.
It's just a coincidence. Remember what you do. You take half of that number. Half of 8 is 4. And 4 squared is 16.
Oh, you should put the plus blanks over here too.
You think
Right
so?
off just so you don't forget it.
And wow, this looks an awful lot like that problem that we just did. Are you sure it's not the same one?
No, almost exactly the first one equals 64.
Okay, you're right. The number on the right is different, okay? What number are we going to put here in this blank here?
1.
Another 1. Half of 2 is 1. 1 squared is 1, so we put our plus 1. And then I'm going to factor the x terms. Let me write my little parentheses. And I have a square. Variable. I'll get us started. The variable is x. What sign will I have? Plus. Be careful. And it's a minus. Variable. Sign. Then half of that number, 4. Now the y terms. Variable. What letter am I going to write here? Y. Sign. What sign am I going to put? Plus or minus? Plus. Okay. Variable. Sign. Half of that number. What have we got on the right-hand side? Okay, 8 plus 16 is 24, plus 1, I agree with 25. So, if we're going to draw the graph, we need to know the center and the radius. So, can you draw it over there too? Center. Is it just me? I see the stuff better when it's when the lights are dimmed, right? Oh, okay. Now, if we forget to do that, anyone out there can walk over and dim the lights, okay? So, change sign. So what's the center? 4, -1. Radius?
5.
You take the square root of that number, which I agree is 5. So we have to draw the graph. The circle is centered once again at 4, -1. I hope they're not incrementing in units of 2 this time. I hope they're incrementing. Good. This is a better first problem.
Yeah.
So the center is at 4, -1.
4, -1, I'm there.
The radius is 5. What do y'all want to do? Count up, down, left, or right?
1, 2, 3, 4, 5.
You could count up, down, left, or right. Save it. Any questions there?
Have y'all noticed something about these problems? Every one of these equations, well, what about over here? When we were factoring these, did we have a number in front of these x's? Look, could I've had a 3 right here and it been a perfect square trinomial? No, because, there would have had to have been a 3 here or there.
Remember also, for center radius form, it has to just be an x. You can't have a coefficient on the variable in those parentheses. It's just an x that's being squared and a y that's being squared. So to get it in center radius form, you can't have a number in front of the squared variable. Okay?
Now, looking at problem 10, let me think. Yeah, this one's okay. It's not going to wind up with the same answer as the other one.
Good.
But what is different about this one? Yeah, we're not graphing it. It just says find the center and radius.
Numbers in front of the
There's a number in front of the x.
A number in front of x squared and a number in front of y squared.
What? What do y'all think we're going to have to do to this one? There's a first step that we have to do on this one that we didn't have to do on any of the other ones. We've got to get rid of this 2 in front of the x squared. What would undo that? Would subtracting 2 or dividing 2 cancel out this 2 right here? Dividing 2. You're going to have to divide straight through by 2. Then I think it's going to look very much like number 9.
Notice I'm dividing each term by 2. That's the same thing as multiplying by 1/2, but then it looks, once we do this, it's going to look very similar to numbers 8 and 9. 2 divided by 2, that gives me 1x squared plus here, y squared,
6 squared,
plus
6x.
Okay, minus
4y.
Here, minus
3, 2.
equals 0 divided by 2 is still 0. If you have a coefficient in front of x squared and y squared, you're going to have to divide through before you do anything else.
Now is it very much like number 9? Yeah.
Oh, and I should note something else. Notice when an equation is written in center radius form, they're both x's and y's there. So when you're foiling it out, you're getting x squares and y squares. The only way you can get a number in front of x squared and y squared is to multiply through by all of that. And if you multiply through by all of that stuff, then x squared and y squared will have the same coefficient. So my point is, you don't have to worry. Suppose there's a 2 in front of the x squared and a 3 in front of the y squared. That can't happen with circles. In that event, your equation's representing some other conic, probably an ellipse. But for circles, the number in front of x squared and y squared must be the same. And if there's a number other other than the assumed one, you're going to have to divide through by that. So now let's group the x terms together.
Write it over here.
Okay. Oh, I see what you're saying. So we have an x squared plus 6x plus, skip some space, and then y squared minus 4y plus, skip some space, is equal to, what do we have over here? A 3, and remember there's going to be two other numbers we have to add, the red blank and the blue blank. So plus and plus. Okay, we have to create a perfect square trinomial. What number's going to go into this blank? Remember, you start with the coefficient of the unsquared variable. You have to do two things. What is it? Take half of it. You know, okay, so 6 over 2 is 3. And then what do? Square it. 3 squared is 9. So we put a 9 right there.
Bless you.
Oh, thank you. Here.
And we put it over here. What's going to go in the blue blank? Yeah, I think you're right. Take half of 4. That's 2, and 2 squared is 4, so you're back at 4. And I shouldn't point out something. I don't know if Tony pointed this out or not. I don't worry about the sign in front of that number, because remember, you're going to square the result. When you square the result, whether it's positive or negative, the result will always be positive. Now we can factor. We're going to get this into center radius form. Let's factor the x terms first. Variable. Okay. The sign is that first sign there. So plus, and half of 6 is 3. What about the y terms? Y, and I couldn't hear you?
-2.
-2, I agree. Variable, sign, half of that number. What have we got on the right?
16.
That's a 12 plus 4, I agree with 16. So let's determine the center. What's the center?
-3, +2.
Okay, change sign, I agree with -3, +2. Radius,
4.
you take the square root of that number there. The square root of 16 is 4.
I think this one's just a multiple choice. No
Yeah.
laughing on it.
Okay, so we need a radius of 4 and a center of -3, 2.
Let's see. Look.
Look,
Okay, so it's either A or D. It is.
I think it's A.
Is it A? Look at this. Let's take a couple of special cases. 3 special cases.
Okay. First of all, any questions here on number 10? Now, let's look at this. We said that this number over here needs to be positive, so you can take the square root and you get a radius. Suppose, okay, we have some
Let's
special
state a couple of special cases.
cases. The first special case. Look back over here. Suppose we had a 0. Suppose this number turned out to be 0. And you say, well, how would that happen? Well, if this thing started off negative here, and you wound up adding 64 here, you could wind up with a 0 over here.
This 64 has been a -17.
Mm-hmm.
Then you would have wound up with a 0. Right here.
So if this is 0, when you take the square root of that number, what are you going to get? What's the
0.
square root of 0? 0?
So if we had a circle with a radius of 0, we wouldn't really have a circle. What would we have?
We'd have that center point, but how many units up, down, left, or right would we have? None. We would just have that center point. You don't move up, down, left, or right. So if the radius is 0, we conclude The graph is just the center point.
That's one special case. If the radius turned out to be 0.
The second special case, we've said that this number over here, when it's written in center radius form, this number needs to be a positive number. Suppose it were negative. If this number here turned out to be negative, you'd try to find the radius. The square root of a negative number, that's imaginary.
Y'all think we could have a circle with a radius 3i or 4i, an imaginary number?
If that number over here is negative, if that radius is imaginary, there is no point, not even a circle. I will say,
No graph at all.
no graph at all. Not even a circle, not even a point. No graph, not even a point.
And how did you recognize those? Well, if the number on the right-hand side turns out to be negative, and you get an imaginary number as the radius.
And I want to point out, why is there not even a graph of the point? Why is there not even a center point? If that radius is imaginary, suppose this number were negative. Suppose that were a negative 81. Don't make the change in your work, okay? Just listen. If that were negative, remember this stuff here is being squared. So no matter what's inside the parentheses, when you square it, what sort of a result are you going to get? Positive plus positive. Can a positive plus positive equal a negative number? No. That's why if that radius turns out to be imaginary, you don't even have a center point. You have nothing.
And then go ahead and mention, what if there's no exponents? There's one other third case.
Suppose your equation, there are no exponents.
What did we say?
That's the first thing we graphed, I think,
Yeah,
in
and
this
the
course.
last time the last time we met.
You're right, we had a whole class over lines.
Yeah,
didn't
you
we?
said it. So if there's
Oh,
no
I did say
exponents,
it.
then
Oops.
it's not a circle.
The graph is a line. Oh, I didn't mean to say that.
Now, why are we mentioning this? Well, let's look at number, I think 12 is a really good one to do.
Okay.
Oh, look.
Yep.
Okay, big. Okay, yeah. You see, the number 6 was appearing too much. And so,
Okay.
That helps.
so here, look at all these instructions. It says, decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, describe the graph. Like, if you look at these choices, answer A says the graph of the equation is a line.
Well,
So if
that's
you're gonna-
clearly not it, because you have exponents.
Yeah, you would only choose that one if there were no exponents, and a student once told me that never happens. Okay, but they're still listed. Okay.
Not in this assignment,
Yeah,
but
in
they
this
graph
assignment,
plenty
yeah.
of lines in the
Oh,
course,
yeah.
just not.
Not in this. Okay, and what I used to dislike these instructions because I was afraid it made it sound like you're supposed to just look at it and tell, oh, it's a point, or oh, it's a non-existent graph. No. In order to figure out, the only thing you can look at it and say is, it's definitely not a line. But to find out if it's a point, or if it's a circle with a center and radius, or if it's non-existent, you've got to go all the way through the work until you get to that last step of finding the radius. Okay? If that radius turns out to be 0,
Yep.
it's just a point. If the radius turns out to be imaginary, no graph, non-existent graph is what I think they say.
They're trying to say, be fancy. I think they should just say there's no graph.
Yeah, but they say non-existent.
Okay.
So you start off the same way you did the other ones. Hey, do we have to divide through by anything like we did on number 10? No. If you look at these answers, it's choices. Answer A says the graph of the equation is a line. But if you look at these answers, it's choices. Answer A says the graph of the equation is a circle. I know. Nothing to divide through, Bob.
Notice the coefficients for x squared and y squared are already just positive 1, so we don't have to divide by anything. We'll group the x terms, x squared plus 2x plus,
So we'll just put a black.
oh, I'll do a red one right there. And then I put my y terms together, my y squared plus, no, not plus, minus
I was
8y
about to say.
plus, skip a
When you're doing that,
space.
make sure you're taking the sign in front of the thing. And you almost messed up
I
there.
know, I did. Move the 21 over, it becomes a negative 21.
Put your blue blank and your red blank.
Can you zoom in a little bit more so I can see
Oh,
that right there?
yeah.
Okay. What number's going to go in the red blank? Okay, you take half of 2. Half of 2 is 1.
You didn't put your red blank and blue blank.
And then 1 squared is 1. You're right. Thanks for reminding me. So we're going to put 1 in the red blank, there and there. What's going to go in the blue blank? 16, I agree. You took half of 8. Half of 8 is 4. And then 4 squared is 16, so I agree. 16 and 16. Then we can factor. Factor. Let's factor the x terms. What am I going to have inside these parentheses? Okay, I agree. Variable, sign, half of that number. What are we going to have inside the blue parentheses? Y minus 4, I agree. Variable, sign, half of that number. What are we going to have on the right-hand side? I couldn't hear you. Negative 4. Negative 21 plus 1 is negative 20 plus 16. We have negative 4. So, if we try to take the radius, find the radius, the square root of negative 4, what sort of a number are we about to get? Imaginary? The radius is imaginary, so there is no graph, not even a point. So we would choose the option
Non-existent.
Non-existent.
I think is what they call it. But you see, it sure sounds like, oh, you look at the equation and decide. No, you don't decide until you're actually.
I'd like it better if the instructions said, write the equation in center radius form, and then decide, you know, but
There's another one of those. Number, oh wait.
Any questions here on number,
They just, look at the, oh well, okay.
oh, I don't like all those 3s.
Oh, not 6s.
6s, I know, okay, right. But we're going to have 3s inside the parentheses.
Okay,
Oh, I
there.
like that.
Okay, this one's better.
But first of all, I was going to ask him again. Any questions on number 12? Okay. Number 13. There we go. Let me write the problem down.
X squared plus y squared minus 2x minus 10y plus 26 equals 0.
Okay. Okay.
If you're going to just guess wildly, do not guess that it's a line. How do you know that can't be right? Well, there's exponents.
So I'm going to group the x terms together. I have an x squared minus 2x
So took that
plus
sign with it.
Yeah, notice I took that minus sign with the 2. That's how I'm deciding what goes there, whether it's a plus or a minus.
Sometimes students will ask me, is it always going to be plus? And absolutely, the only way you're going to have a perfect square trinomial is if that second sign is plus right there. Okay? If it had been minus, you would have a plus and a minus. It wouldn't be a perfect square trinomial.
And then y squared minus 10y plus, skip some space, equals, what have we got here? Negative 26. Move that over so it becomes a negative 26. And I have the plus red blank and the plus blue blank. I agree.
Perfect.
Half of 2 is 1. 1 times 1 is 1. So we put a 1 in the red blank. Good. And 25, I agree. The vocal minority sure has got the hang of this. 10 divided by 2 is 5. 5 squared is 25. I agree. I took this positive 26, moved it over, and it became a negative 26. Yeah, right there. Look back over here at this. Okay, look at this one. How'd I get the negative 21?
Yeah, put the arrow.
I took that positive 21, I moved it over, it became a negative 21. Okay? And I'll tell you right now, that is a very common mistake. People just put it, that 21, it stays at, even though you know, oh, I moved it to the other side of the equal sign, I need to change the sign. That's something that you just, with all the other new stuff, you just don't think that, okay? So be careful.
Move it down.
Then, oh yeah, move it down there. So, we're grouping the X terms together.
I think someone was trying to say something.
Uh-oh. Did I?
Added the numbers over here on the right.
It's going to be 0.
Does it need to do anything else?
Do I?
Oh, wait, actually, I think you are going to have to do more.
Well, you have to find the center.
Yeah,
Yeah.
you got to find the
So we
center.
do need to factor.
Uh-huh.
What are we going to have here inside the parentheses? Okay, good. And the blue parentheses. Good.
Oh, it has.